So without any further waste of time, I'm already excited about the questions that you're saying to us, guys. And the first one that I'm going to be looking at comes from Marvin, right? So Marvin, this one is nice because you can see that Marvin was in class as a regular Tenfold show watcher, or a person who watches Tenfold live. He just decided to take a photo of what was happening in class. This is like on the board, right? On the blackboard, right? Took a photo and then sent us this particular question. So let's look at it and see what is going on with this question, right? So Marvin's question is based on Euclidean geometry, okay? You can see they wrote there in class using chalk. Clearly it's evident here on the board. It's question 2 with a very nice circle. Well done, Marvin. I struggle to draw circles that are as perfect as this one of yours. All right, like as always, in every Euclidean geometry question, there is always a love letter that you get. Please always make sure that you read the love letter before you can even start looking at the questions that are on that particular question. So the love letter that is appearing in this particular question reads as follows. It says, in the diagram, LK is a diameter of the circle with the center at P, okay? So we clearly can see where that LK is. That's the diameter of this particular circle. That is definitely that particular line, okay? And we already see that point P will be the center of this particular circle. Awesome stuff, right? Now the statement proceeds and says RNS is a tangent, okay? So very important things here. This here is a diameter, okay? You've got to know something about those kinds of things, okay? And this one here is simply a tangent to this particular circle, right? At point N. T is a point on NK, and TP is perpendicular to KL. What does that mean? Well, that just means the angle 90 degrees. We've got an angle of 90 here at point P in that particular corner. We're very excited to see that. It means a whole lot of very exciting things that we can conclude in this particular question. All right. And then we are told that angle PLN equals X. First question, prove that TPLN is a cyclic quad. Okay, Marvin. Now, remember, if anybody asks you to prove that something is a cyclic quadrilateral, first of all, you will be dealing with a four-sided figure, right? There won't be any complete circle around that particular quadrilateral, right? If you want to prove that a quadrilateral is a cyclic quad, there's about 3 things that you can look for, right? There's 3 cases. The first case, you just try to prove that the opposite sides of this quadrilateral add up to 180 degrees. If you can succeed to do that, then you have succeeded to prove that whatever quadrilateral you're looking at is a cyclic quad. The second case that you can use to try and prove that something is a cyclic quad is just try to prove that in that particular quadrilateral, there's some exterior angle that happens to be equal to another interior opposite angle. If you can succeed to prove that the exterior angle in that quadrilateral equals to the interior opposite angles, then that means that you're looking at a cyclic quad, right? The third case here, beautiful people, is where we need to prove what I call the bow tie. You basically try to prove that an angle that is positioned like this is the same as that angle there. If you can succeed to prove this, then you can claim that if a particular chord subtends equal angles, if you can succeed to prove that a line subtends equal angles, then it means that you are dealing with a situation that can conversely be thought of as angles on the same segment, subtended by either the same arc or the same chord. So you just need to prove that those angles are equal. If you can succeed to do that, then you can then claim that you are looking at a cyclic quadrilateral. Okay, cool. So I don't know which one of these 3 cases we're going to go for, but let's go back and check the diagram that was given to us. Now, so far, I was told that we've got an angle of 90 degrees, okay? That is basically 90 degrees. I'm happy to see that that angle P there is equal to 90 degrees. But if LK is a diameter, you guys should know that in any circle, if you've got a circle and you've got a diameter, an angle subtended by the diameter will always equal 90 degrees. So that's basically where I'm going to rely my argument. I'm going to claim that this angle L2 is 90 degrees. And clearly, I'm sure you can see immediately that if angle N2 is 90 degrees, we already have angle P as 90 degrees as well. So I'll have a situation where opposite angles add up to 180, and then I can claim that you're looking at a cyclic quad. All right, cool. So let's put it officially. First of all, I'm going to claim that angle N2 is equal to 90 degrees. Why am I saying this? This is an angle on a semicircle, or an angle subtended by diameter. Okay, but we've got another angle here. Which angle is that? We've got an angle there, which is angle LPT. That angle is also 90 degrees, okay? So, but LPT is also equal to 90 degrees, and this information was given to us because we were told, remember you guys, we were told that TP is perpendicular to KL. We were told that TP is perpendicular to KL. You can also say it is given to us, okay? Therefore, angle N2 plus LPT is equal to 90 plus 90, which is 180 degrees. Therefore, the quadrilateral that we are looking at is definitely going to be a cyclic quad. So I can then conclude from here that indeed TPLN is a cyclic quad. Why am I saying this? Because opposite angles, okay, add up to 180 degrees, which means opposite angles are supplementary. You can even say that opposite angles add up to 180 degrees, or opposite angles are supplementary. Awesome question indeed. I hope you now see what you had to do in that particular case. All right, now let's go on to 2.2. 2.2 says we now need to determine, giving reasons, the size of angle N1, okay? Let's go back and check what is happening with angle N1. Okay, angle N1 is this angle that is appearing this side. This is basically where angle N1 currently lies. So we are interested in finding this angle. And according to this question that Marvin sent to us, they are saying we need to find, giving reasons, the size of angle N1 in terms of x. Now, this whole concept of asking people to find things in terms of something else proves to be a problem for a lot of people, right? When I say find A in terms of B, I'm asking you to solve for A, but your answer will have B inside, okay? So don't be worried about finding what B is going to be. So in this case, we want angle N1 in terms of x. So we are solving for N1, but in our answer, we are going to definitely see an x there, and there's nothing wrong with that. That's basically what we're looking for. We want angle N1, your answer will contain x. That is the meaning of in terms of x, okay? All right, so let's check what is going to happen in this case. Now, if you look here, remember we've got a tangent. So I'm going to use this idea that if you've got a circle, right, and you've got a tangent, and then you've got an angle subtended by that particular tangent, I'm basically trying to relate angle N1 with the triangle that we're dealing with. So that angle there is definitely equal to angle K, and this is via the tan-chord theorem. So that's basically what I'm going to use in this case. So I'll first of all say angle N1 is equal to angle K tan-chord. All right, full. Okay, cool. So that's basically angle question 2.2. We're now doing 2.2. So I'm going to first of all say, okay, this angle N1 we are looking for is equal to angle K. The reason for that is this is a tan-chord relationship, right? But what is the story with angle K and X, right? But in that triangle that you guys had there, the big triangle, the right angle triangle I spoke about, L in triangle LNK, okay? We have a 90-degree angle there. Let's go back and look at it, okay? Look at it. LNK is a right-angled triangle. If I had to draw on it, I will be basically looking at this particular triangle here, right? So we have an angle X there already. We have a 90-degree angle here already, so you can be able to figure out what the value of angle K is. And I'm sure you'll agree with me that it will be 90 degrees minus X, right? So I'm going to say in that particular triangle, angle L plus angle K plus angle N2 is supposed to be 180 degrees. The reason is this is the sum of the interior angles of a triangle, add up to 180 degrees. We already know that L is X, okay? We are looking for angle K, and we were told, in fact, we did conclude that angle N2 is going to be 90 degrees. Therefore, it means angle K will just simply be 90 degrees minus X. When you subtract 90 and x on both sides of the equation, right? Okay, therefore, we can then conclude that angle N1 is also equal to 90 degrees minus K because minus X because it is equal to that particular angle, which is angle K. Right. So a very awesome question indeed. Thank you very much. It's always nice to see that when you are working at school with whatever that you could be interested in, when you find challenges, you know where you're going to get your help by just contacting us on Tenfold Live, either using the app. We really appreciate all those questions you send in to us. So thank you very much. I hope you see what you had to do on that one.